Hello learners, welcome back to our channel Robotics Labs. Today we are going to explore a concept-based engineering project, a servo-controlled drone payload release mechanism. This system demonstrates how controlled mechanical release systems work in robotics, especially in delivery, rescue, and automation applications. Before we begin, let's take a look at the components you will need. An Arduino UNO, a Micro Servo Motor, jumper wires, a 5-volt power source, 3D printed mounting parts, a screwdriver, 2 bolts, and lightweight sample payload objects for testing. You can find the 3D printed design files linked in the description below. So let's get started. Assemble the 3D printed payload holder mechanism on a stable drone frame or a ground test platform. Make sure the structure is lightweight and properly balanced so the mechanism can operate smoothly. Now, fix the servo motor onto the locking section of the payload holder. The servo acts as the main actuator that controls whether the payload is locked or released. At the 0 degree position, the latch remains closed and the payload is secured. At the 90 degree position, the latch opens and the payload is released. This simple motion demonstrates a real-world electromechanical release system used in robotics. Now let's move on to the connections. Connect the servo motor to the Arduino UNO. Red wire to 5 volt, brown or black wire to ground, signal wire to digital pin 6. Once everything is connected, double check all wiring carefully using the circuit diagram provided. Now copy the code, open the Arduino IDE and paste it. In this project, we use the built-in library servo.h. At the top of the code, we include the library include servo.h, servo 6. In the setup function, we attach the servo to pin 6, servo6.attach 6. Now in the main logic, we control the release mechanism using angle commands. Servo6.write 0, lock position, payload secured. Servo6.write 90, open position, payload released. A delay is added to ensure the servo completes its movement before switching states again. So the logic works like this. System idle, payload locked. Trigger signal, servo opens the latch. Reset, servo returns to the lock position. Now connect the Arduino to the computer using a USB cable. Select the correct board and port in the Arduino IDE and upload the code. Your DIY drone payload release mechanism is now ready to use. Now test the mechanism on a table setup, trigger the servo, and observe how the locking system opens and closes smoothly. Always test the system without flight or aerial use during learning and development stages. Safety note: this project is made only for learning and understanding how a payload release mechanism works. Always test it on a table using light objects. Never drop anything from a flying drone as it can be dangerous. If you are doing this project, make sure an adult is with you and always follow your local rules and safety guidelines. These upgrades help evolve this into a real robotics payload delivery research platform. This project is a great example of how servo systems and microcontrollers are used in automation, robotics, and controlled mechanical systems. If you enjoyed this concept build, don't forget to like, share, and subscribe to Propelx Labs for more exciting DIY builds. Thanks for watching, and we will see you in the next one.